In this video, we are going to see how do we solve simple increasing annuity and loan schedules in our Excel. Let's take this question into consideration. A loan of 60,000 was granted on 1st July 1998. The loan is repayable by an annuity payable quarterly in arrears for 20 years. The amount of the quarterly repayment increased by 100 after every 4 years. The repayment were calculated using the rate of interest of 8% per annum convertible quarterly. Calculate the initial quarterly repayment and make 20 years loan schedule. So here clearly we have a simple increase question. So first of all, we'll try to calculate our initial quarterly repayment, then we'll make our loan schedules. So first we'll write a few values that are given. So first they have given us the loan is of 60,000. So our loan 60,000. Our interest rate, they have given us I4. They have not given us I. So our I4 is given as 8%. I'll write it as 8%. Then we can calculate our I. So our I would be, whenever we are writing a formula, we'll always start it with equal to. We'll have equal to, and our formula would be 1 plus I4 by 4 the whole raised to 4 minus 1. So we'll put our bracket 1 plus our I4, we'll take it from the upper value, so just press that. So I'll click that. So you can see they have given us B2. B2 is nothing but the cell value, or sorry, cell destination. You can see cell name. You can see clearly it's the B column and our second row. So we have B2. So 1 plus B2, bracket close, we'll say raised to, that is our shift 6 raised to 4 minus 1. So we'll press enter. It is giving me 36. Let me just check the formula. Okay, sorry. It should be 1 plus I4 by 4. Now if there is some problem and you need to edit that particular equation, you can see here they have given us just a value. If you want to edit, here you can see there is a formula. This is called as a formula bar. So you have to click in the formula bar and you can edit your formula here. So divided by 4. So we will have 1 plus I4 by 4 raised to 4 minus 1, enter. Now if this particular term comes in not in the percentage form, it must look something like this. If you want to write this in percentage form, all you have to do is, this becomes our cell format. What kind of format this particular cell should be in. So just click here and you can see there is a percentage. Click percentage and it is going to give you 8.24. You can just click this button as well. This also converts into percentage, but as you can see it has rounded it down to 8%. We do not want round, so we'll just click this. It is going to give you 8%. Next, our initial installment. Now our initial installment is what we need to find, but to complete this table we require initial installment. So we'll assume that our initial installment is 1000. You can assume any value. It is just so that we'll be able to complete our table. So you can assume any value. Now let's start making the table. Now first of all, they have given us date. Now date column is not at all necessary. You can skip this, but I want to talk about how do we write our date. So our first date is 1st July 1998. So we'll have 1-7-1998. As soon as you write your date, it recognizes that format is a date format, and you can see this particular term here, format, became date. Now if you drag it down, it recognizes that you need to increase the date, and it is increasing. 1st July, then we have 2nd July, 3rd July, and so on. Now by chance, if this seems to be in format of months, date and then year, you can change that by going to this more format and change it here. Now our dates, we do not want our dates to be every day, but we want every 3 months because our payments are quarterly. So we'll change our second date. We'll write our second date to be our 1/10/1998. That is going to be our second date. And then if you select these two and drag, it will take that date and continue the gap of 3 months. And we have to go till 20 years. That will be our 2018. So you can see above my cursor, you can see that they are showing us what is the current date that we are dragging down to. So you can see we can go up till our 2018 and we want our first July 2018 to be our last installment. So you can basically create our date in this particular manner. Now we want actually our time. The time value is going to be what is important to us. So our time value starts from 0. This is when we took our loan, and then installments are 0.25. So our gap of time should be of 0.25. Just select these two and drag till our last date, and you can see each date, each time is basically a difference of 0.25. So this becomes our quarter till time 20. So this is how we'll make our time column. Next would be we'll make our discounting factor. So our VT. So our VT discounting factor. In our discounting factor, again it's an equation. We'll say equal to our 1 plus I raised to t. So I value must be this particular 8.24. We'll select that, bracket close, for raised to, again 6, shift 6, raised to, we want this time period, that will be this. Select that and press enter. So discounting for time 0 should be 1. That is okay. Okay, I did not write minus. We should have minus t. Enter. Now what you will do is you will drag it down. Now if you drag it down, you will see some inconsistencies. We are getting some 1, some value or something like that. So there are some problems here. Now what is the problem? If you see that function, first function we had our 1 plus I, that was our B3, raised to minus B9, that was our T. For second, what we are expecting is that B9 becomes B10. That is okay. For third, our B9 becomes B11 and so on. That is okay. We want corresponding time. But if you see, our B3 became B5. In our second, B3 became B4. We do not want that to happen. So if we do not want our cell value to change in our formula, what we do is, now go back to our editing that formula and we put $sign. So if you put $sign before B, it is not going to change your column if you drag it horizontally. But in this question we are only doing vertical, so all you need is a $sign before 3. But I always write, if I do not want to change the sign, I always write $sign in both of them. So we'll have $B, $3. That just says that we are not going to change this value, that is our B3. Now if you drag down and see our second value, it is 1 plus again B3 raised to minus B10. So we wanted B10, that is okay. In the third one we have 1 plus B3 raised to minus B11 and so on. So this formula is correct. It is not changing our I value, but it is changing our T value. So drag it down till 20 years and it will give you all the discounting factors. Next we'll calculate our installments. Our installments, we'll say equal to this particular term. Now we do not want this to change. That is why again in our formula we should put $sign. So we'll have $B, $4. We do not want this to change. So 1000. If I drag it down, I am saying that now first of all, our installment starts from time 0.25, not time 0, so we should not have any value here. This should be our first value, and then we should drag it down till time 20. So we drag it. Now this says that we have an installment of 1000 every quarter for 20 years. Now, but that is not the case. We have an increase of 100. Now, whenever you have an increase, simple or compound, what we do is we make a counter value. That is just going to count how many increase have already happened, or how many increase do we need to do in this particular term or this particular time. So for that, I make a counter column. Select C and right click, insert. It is going to insert a column before that particular column. So now I have created another column. Here I'll write this as counter. This is going to count how many increase have I already done and how many increase will I do next. So for counter, we would want it to increase according to whenever we need to increase our installment value. So for that, I do not want an increase of 0.25 every single time. So I am not going to use this time t. I will make a separate counter. So for counter, what we do is we say equal to. Now we need to make a particular function such that it is going to increase only after some period of time. One of them is integer. We'll say int. So integer is going to, you can clearly see as soon as I wrote int, it showed me there is a function called int, and what does it do? Rounds a number down to the nearest integer. So it is going to round down the number to the nearest integer, and if you press tab, it is going to use that particular function. It understands that yes, we are going to use that function, and it gave us this. Now it is asking for a number, so we'll give it a number 0.25 and press enter. So it is rounding it down to 0. We can see that if I just do that, you can clearly see 0, 0, 0, and then 1, 1.25, and so on, 2, 2, 3, 4, and so on. Now if I had increase every single year, I would have done in this particular manner, but our increase is not once 1 year. We have increase once every 4 years. So we want this to be 0 from 0.25 to 4, and then increase to 1 from 4.25 to 8, and then to 2, and so on. So for that, what we'll do is we'll divide this our B10 by 4. We divide it by 4, press enter. Now it is going to take this t value divided by 4 and then try to find what is the integer. So up till time 4, basically it is going to see that whatever divided by 4 was 0 point something something. At 4 it became 1. After 4, 4.25 became 1 point something something, and that is why the integer round down is going to give me 1. I'll drag it down more. Now still this is not correct, because our installment at time 4 is basically the installment, last installment of our 3rd year. So here we should not have 1, we should have 0. Our increase must start from the first payment of our 4th year, that is going to be 4.25. So this should be 0, and clearly this 8 should be 1, not 2. Our 12 should be 2, not 3. So for that, what we can do is, instead of selecting our B10, that will be the corresponding value, we'll be selecting B9. We are selecting the previous value, B9. You can see we are selecting the previous value, and if I drag it down till 20, you will see now at time 4 it is actually taking B24, that is the previous value, that is 3.75. so it is still counting it as 0. And from 4.25 it took the first value, that is 4, and that is why it got the integer 1. So in this manner we can basically make a counter. Now this counter is helpful not only in our simple increase but also in our compound increase, and we'll see that in later videos. So we'll use this counter to actually make our installments correct. So our installment should be our 1000 plus 100 after the 4th year. So this counter 0 into 100 should give us the correct value. This becomes our installment. So at time 0 till time 4 nothing is going to change, it will stay 1000. But as soon as I drag it down to the next value, you can clearly see it became 1100 because our counter was 1, so it multiplied by that value. Then you will see till time 8 it will be 1100, and as soon as I go down to 8.1 it became 8.25, it became 1200. So this must be correct, and I'll drag it down till the last value, that is 20, and it will give me all the exact installments. So this is the reason we took a particular installment, that is 1000, just to check that our increase was correct or not. And also we require this for our further things. Now this becomes our installment. We'll calculate our present value of our installment. So present value of our installment, what we have to do, we'll just say that will be equal to our installment into, that is our shift 8, into our discounting factor. So this becomes our present value. We can drag it down till 20. It will give us all our discounted values. So this becomes our present value of our individual installment. We need to add them. So we'll say equal to, now for addition we have a function called sum. If you press sum, you will see that it gives you the function sum. Now if you wanted to use sum if or sum f or any of the function other than that, you will just press lower arrow and it will go down to that sum, but we require sum. And then press tab. So as soon as you press tab, it understands that you are basically doing a sum. Now you can see it is saying sum and number 1. It is asking us to give the number, first number. So let's say this was our first number. I will select this, then I'll press comma, give it a second number, that would be, let's say this, comma, third number, let's say this, comma, fourth number, let's say this. So if I have individual numbers, I can select this way and separate them with comma, and if I press enter, it will give me the sum of those numbers. You can clearly see here it is adding all of these 4 numbers, but in actuality we require sum of all these whatever 80 numbers or something like that. So we'll say equal to sum tab, just a minute, I'll have to remove this, and we'll say equal to sum tab, so it will understand we are using that sum function, and select all the values, just select and drag all the values that we need to sum. Again select and drag till the last value, that is this 20 time 20, and press enter. It will add up all the values. You can check it is adding from F10 to F89. So our sum present value of our installments comes out to be 45,278. So clearly it is not the present value of our loan. So therefore our installment must not be 1000. So to basically find that, what we'll do is we'll say NPV, our net present value, that should be equal to our present value of our installments, that was this, minus loan, that was this, enter. So we have a net present value of minus 14,000. We need that net present value to be 0. So for that, what we do is we have something called a goal seek. In data, if you go to data, you will find here what if analysis, and what if analysis you find goal seek. This goal seek is what we are going to use to find our installments. So first you have to set a cell. You can set any cell, but what we are trying to do is we are trying to make this net present value 0. So this net present value, we have selected that cell, and to value we need to decrease that value to 0. So we'll say we want that value to be 0, to value 0, by changing what cell? So we want to change the installment cell. So therefore installment cell, and then enter. You can see it changed the installment value such that a net present value becomes 0. You can set it to any value. We could have set our present value to 60,000 and then change that. So you can clearly see that our installment value, first installment value is 1370.409, and the increase you will see here 1470, then 1570, and so on. So this is how we will basically find our installment value by using the function goal seek. Now we'll talk about making loan schedules. You can make loan schedules as a separate table, but I'll make it here because we'll require this installment column. Installment column is required in our loan schedules. Other than that, what the columns that we require is going to be our interest. That becomes our interest component. Then we'll have a capital component, and we'll have our loan outstanding. So loan outstanding at time 0. So we have our time. Loan outstanding at time 0 is going to be 60,000. You can directly write 60,000 or just press equal to, and here we have written our loan amount. Enter. So this becomes our loan outstanding at time 0. Then interest, our interest component should be equal to our loan outstanding into our I4 by 4. This is our I4. We do not want this value to change. So therefore we should write our $B $2. $B $2. And this is I4, we will divide it by 4. So I4 by 4. This becomes our interest component. Our capital component will be equal to our installments minus our interest component, and then loan outstanding will be equal to our previous loan outstanding. So select the previous value minus our capital outstanding, capital component. Enter. All you have to do is complete this table. So this becomes our interest component. This becomes our capital component, and then loan outstanding. As soon as you complete the whole table, you will find they will rearrange each value to give you the exact value. So now interest values, capital values, loan outstanding values, such that after 20 years your loan outstanding is almost equal to 0. This is not exactly 0 because of the decimal values that they have taken, the number of decimal points, but you can see it is minus 7.7 e raised to minus 11, that is 10 raised to minus 11. That is basically almost equal to 0. That is because of the limitations of the number of digits in decimal points that they have taken. So this becomes our loan schedules. By chance, if they ask you what was the interest in the 4th year, so interest in the 4th year will be interest from installment of 3.25 to 4. So you'll say your interest component in 4th year, year 4, that should be equal to, you will say sum tab, and you will add up these values from 3.25 to 4. That is your interest component. So this value to add up, drag it down to 4. I have selected more values. It should go from 3.25 to 4, and press enter. So 4590.875 4, this much is the interest that was paid in 4th year. Similarly, you can calculate your capital component, just capital paid in how many ever years they might have asked, and you can basically select and find that values. So this is how basically we solve our simple increasing annuity as well as our loan schedules.